In this video, we're going to talk about how to solve inequalities, okay? And we're going to also talk about how to graph their solutions, okay? So we have a few examples to get through here, and so let's go ahead and get started. So first thing, just like if this was an equality set, or an equality question, first thing that we would do in this is add 2 to both sides, right? Goal is to get x by itself. Okay, so we would end up having 3x on this side. The sign of the inequality does not change, so we copy it down as less than. And then negative 11 plus 2 is negative 9. Okay, next step, divide both sides by 3, and we get x is less than negative 9 divided by 3 is negative 3. Okay, so if you were to write your solution in set notation, you'd say x such that x is less than negative 3. If you were to write in interval notation, if we're less than negative 3, that means we go all the way from negative infinity to 3. Okay, so this is called set notation, and this is called interval notation. Alright, so both of those, two different ways of writing the same answer. So if we were to graph this solution, so here's 0, 1, 2, 3, here's negative 3, negative 2, negative 1, 1, 2, 3, 1, 2, 3. Okay, so this is your number line. And so at negative 3, we have an open circle because we're strictly less than negative 3. And we would just shade in the number line in the less than direction. Okay, so that's how you would graph this inequality. Okay, so let's go on and do another example. In this example, so, again, we always start same way. So our goal is to try to get x by itself. So let's go ahead and divide both sides by 4. Okay, get this 4 off of there. And then, so the 4's cancel here. So then we end up having 3 minus 2x is less than or equal to 20 divided by 4 is 5. Okay, of course, I guess you didn't have to start that way. Another way you could have started is you could have distributed the 4, so you'd have 12 minus 8x is less than or equal to 20. Either way, you'll get the same answer. So okay, let's see. We did it this way, and then next step may be to subtract 3 from both sides. So you have negative 2x is less than or equal to 5 minus 3 is 2. Okay, next step, divide both sides by negative 2. And then you get x. Now, this is when you need to be really careful, okay? So, big rule here, you need to always remember that, whenever you divide or multiply both sides of the equation by a negative number, the inequality flips direction, okay? So, instead of it being less than or equal to, now it's greater than or equal to. So, this is negative 1. Okay, so we're greater than or equal to negative 1. Just make sure you remember that rule. If you multiply or divide both sides by a negative number, the inequality flips direction. Okay, so let's see. Now, if we were to write this solution in set notation, you would say x such that x is greater than or equal to negative 1. If you were to write it in interval notation, you would, so x is greater than negative 1, so that means we go from infinity, or actually, sorry, you start at negative 1 and then you go all the way to infinity. So you use the hard bracket because we do include negative 1, and then we go all the way to infinity. Okay? And then if you were to draw this out and using a number line and graph it, here's 1, here's negative 1, negative 2, 2. Okay, so here's negative 1. It's a solid dot because we are, there's greater than or equal to, because of the equal to, it's a solid dot, and then it's greater than, so you shade in the greater than side. Okay. Okay, another example here. So the goal is to get x by itself. We're trying to solve for, see what x is. So let's see, the first thing I'm going to do is go ahead and distribute this 8 inside. So I'll have 3x plus 4 is less than 8x minus 8 minus 5. Okay? And now, let's see, I should maybe combine like terms, maybe bring all like terms on the same side of the equation too. So, okay, so I'm going to combine like terms over here. So I have 8x minus 5x on this side of the equation. So 8x minus 5x is 3x, and then I have the minus 8. Okay, so I'm going to go ahead and, let's see, I'm going to subtract 3x from both sides. Alright, and then I'll be left with 4 is less than or equal to negative 8. Wow, 4 is less than or equal to negative 8. That's not true, right? 4 is greater than negative 8. So this is always false. You know, this is not a true statement. So this is always false. Regardless of what x is, this is a false statement. So, so the solution set is the null set. Solution set is the null set. Okay? So the null or the empty set. Okay, one last example here. Let's see. First thing I'm going to go ahead and do is distribute this 10 inside the parentheses. So I'll have 10x minus 20x, or sorry, 10x minus 20, which is 2 times 10. Okay, plus 17 is greater than, I'll distribute the 5 as well, so I'll have 5x minus, 5x minus 3 times 5, which is 15. Plus 5x. Okay, so let's go ahead and combine like terms. So let's see, negative 20 plus 17 is negative 3. So this is greater than. So let's see, I have 5x and I have a 5x, so that'll make 10x, right? 5x plus 5x is going to make 10x. So I got 10x and then minus the 15. Okay, all right. So let's see. Well, you know, I could subtract 10x from both sides, right? I'll be left with negative 3 is greater than negative 15. And that's an always true statement. Regardless of what x is, you know, negative 3 is always going to be greater than negative 15. So the solution set in this case would be negative infinity to infinity. And if you were to graph this, you would basically shade in the entire number line. Okay, so here's 0, and then you'd shade in the entire number line.